In the last class, we started the conic sections. In the conic sections, we observed how the parabola, ellipse, and hyperbola formed by the intersection of or cutting off a section plane of a right circular cone. After that, we consider eccentricity of the parabola, hyperbola, and ellipse. And based on eccentricity, we developed a method. That method is called as general method or eccentricity method to draw these three conic sections. And we observe that parabola have an eccentricity of 1. Ellipse have eccentricity less than 1. Hyperbola eccentricity is greater than 1. Okay. Based on that, we develop the general method or eccentricity method. After that, we go for the other methods available to draw the ellipse. In that first method, we covered concentric circles method. The second method, we covered arc of circles method. Okay. Now we will go for the other method, oblong method, or the angle in between major axis and minor axis if it is other than 90. It is 75, 60, 30, like that. In such cases also, we can draw the ellipse. That is the reason it is an oblong method. Okay. And this method, if the ellipse axes are at 90 degrees, this method also called as a rectangular method to draw an ellipse. Okay. Now we will take one problem and we will observe the method. The foci of an ellipse are 90 mm apart. Here the foci is given F1 and F2. The distance between these two focuses are 90 mm apart. 90 mm. The minor axis is 65 mm long. The minor axis we can call as CD, and this is 65 mm long. Determine the length of major axis and draw the ellipse by using oblong method. Determine the length of major axis. After that, we need to draw the ellipse by using oblong method. Here, by the property of ellipse, we need to use. After that, we can find the major axis length. First, you need to draw a horizontal line. This is a horizontal line, and locate a point at this. Locate a point here and name it as O. Right. We know minor axis length 65. Above this line 32.5. Below this line 32.5. We need to consider. This is 32.5 and 32.5. Total equal to 65 mm. Let it be CD. Okay. Next one. From O, the total length or the distance in between F1 and F2 equal to 90. Therefore, if it is the center point, from center point here 45, here 45. Now, this is 45. This is F1. Exactly 45 we need to measure and we need to put on the drawing sheet. This is F2. Okay. Now the property of ellipse here, F1 to C, this is the distance, is nothing but half of the major axis or semi-major axis. Consider this distance CF1 or CF2 distance and O as center. With that radius, draw an arc. Let it be cut here, that is A, and here let it be B. Okay, AB is major axis and we need to measure AB length, and it is asked to find in the problem. That is the reason you need to write whatever be the length you got AB, that we need to write here. Now for the oblong method, we need to construct a rectangle parallel to horizontal line through C. Draw a horizontal line and draw a vertical line through B. Right, and here also draw a vertical line through A. Okay, after that draw a horizontal line through D. Okay, and this intersecting point we can call this as P, Q, R, S. Right. Now consider 5 equal divisions. Here we need to consider a number of equal divisions on A to S, as well as whatever be the number of equal divisions you consider on A to S, we need to consider same number of equal divisions on O to A. Okay. Here it is convenient if we consider 5, right? It is convenient if we consider 5 because CD, that is equal to 65, right? And we, suppose if we consider this 5 divisions, that will be 6.5. Divide this AS line into 5 equal divisions. Now see. This is an inclined line at any angle for any length you can draw. After that, consider 5 equal divisions on this. 1, 2, 3, 4, 5. 5 equal divisions we need to consider. Right. After that, draw a line in between the end points. After that, draw parallel line to that line. This gives us 5 equal divisions here. Right. At the same time, divide OA into 5 equal divisions. We need to divide OA into 5 equal divisions. Here also, the OA distance also we don't know. The same methodology we can implement to divide OA into 5 equal divisions. Draw an inclined line of any length with any angle. After that, consider equal divisions on this line. 1, 2, 3, 4, 5. 5 equal divisions. Right? And first we need to connect end points. After that, parallel line to that line through 4. Parallel line to that line through 3. Parallel line to that line through 2 and 1. Okay. We need to draw the lines so that we got 5 equal divisions. Now give the numbering. Here we consider this as 0, this is 1, this is 2, this is 3, this is 4, and this is 5. Okay? Now here is 0, this is 1 dash, this is 2 dash, this is 3 dash, this is 4 dash, this is 5 dash. Okay, likewise we need to consider the points. After that, from C to 1, we need to draw the lines. After that, C to 2, we need to draw the line. After that, C to 3. After that, C to 4. Okay, likewise. Here, from D through 1, we need to draw the line. Okay, next one. From D, we need to draw a line up to 2. After that, extend it up to 2 dash line. Okay, next. After that, from 3 to D, and extend it up to 3 dash line. Okay, after that, 4 to D, and extend it up to 4 dash line. Okay, now this we can name it as P1, P2, P3 and P4, right? These are the points on the profile of the ellipse. Now, considering those points, draw a smooth curve, freehand curve. We need to draw through these points. Okay. By drawing this profile, we got 1/4 portion of the ellipse. And ellipse is symmetric about both major axis and minor axis. Therefore, if you take the mirror image of this on the other side, it will give the remaining 1/4. After that, semi-ellipse is completed. After that, if you take the mirror image of this, then at the bottom we got the other semi-ellipse or remaining semi-ellipse on the bottom. Right. Now, to take the mirror image, again you need to draw horizontal lines. Like this. Right. With the mini drafter, we can draw the horizontal lines very easily. Right. To take the mirror image downwards, draw the vertical lines from P1, P2, P3, P4. Okay. Now, here to P4, whatever be the distance you observed, the same distance you need to put on the other side. Let it be P5. Okay. Next, P3, here to here, whatever be the distance you observed, that you need to locate. Let it be P6. Next, here to here, whatever be the length or distance you observed, you need to put on the other side, here to here, P8. Okay. After that, draw a smooth profile from here. Now, the similar fashion, P1, here, opposite side. You need to locate the point, opposite side. You need to locate the point here. Next, this is P4. Right. You can draw the line. Right. Now, you need to project the P5 downwards, P6 downwards, P7 and P8. Whatever be the distances you observed here to here, the same distance, you can put on the other side. Now draw the smooth curve through this. Okay. Now name it P9, P10, P11, P12. After that, this is P13, P14, P15 and P16. Okay. Now we got the required ellipse by using Oblong method.